Hey guys, Ryan from Spyker Workshop, and today I'm going to do a in-depth video on how to set up these brushless speed controllers. They're also called VESC or FSESC. They're open source brushless speed controllers. They can also work with brushed motors. So I'm going to go through 3 different examples with these. And the advantage to these is they can support 50 amps and have quite a range of voltages. They can go all the way up to 60 volts. And then they come in a few different flavors. So there's, this is the most common one, I believe, but there's many different versions. And this one is a more powerful version, but they're all programmed with the same software. So I'll go over that also. You connect this to a computer and have to get a specific software that's free to use. And there's all sorts of settings you can do, and I'll be walking you through all that stuff too. So first, to talk about the different motor types you can use. These are brushed motors, so you got just 2 wires coming out. And these are used in like my big Spyker KAT, that larger snow cat that I make. And when you run a brushed motor, you basically ignore the middle wire. So a brushed motor, you will connect to the outer 2 wires on the end here. And it doesn't matter which one goes to which, because you can either flip it in the software or flip the connector. And then if we step up to a more powerful motor, these are brushless. They make them in different windings and speeds and stuff. But most of these brushless motors, they'll have 3 wires, or all brushless will. And most of them will have a sensor wire. They can still be run without a sensor wire, so that's kind of an optional step. If you also take the time to set up the sensor, the motor will have better low speed control. Basically, that sensor cable will tell the controller where the motor is, so it has better control at spinning it really slowly. If you don't use that, it's a little more jerky at low speeds because it's trying to find where the next magnet is, kind of. So I'd recommend doing that, and I'll show you how to set that up too. And then this is a similar motor as this one, but it's rated at a lot more current. So to run this size, I can't remember the name offhand. Check the description down below. But this is I think it was 4,000 watts. So I had to step up to this larger controller, which this can support up to, I think, 100 amps. So it's twice what that can do. But it all uses the same software stuff. And then same thing with this, you can also use a brushed motor if you ignore that center wire, or brushless using all 3 and then the sensor cable. So before we talk about the programming and how to set up the controller with the computer, first we need to physically get everything ready. So that will involve, depending on what setup you're using and what power source and stuff you're using, you'll want to put connectors on stuff. So I'm going to put some power connectors on the power input wires. And then depending on if you're using brushed or brushless motor, I'll either be using the 2 wires or all 3. The other, if you're using a brushed with just the 2, just put a piece of heat shrink tube over that, or even cut it off, up to you. So for connectors, here's a XT60 connector. I highly recommend these for most of the wiring. They can handle up to 60 amps continuous, which is fine for either of these, the brushed motors or the medium ranged, like brushless. And this will be good for the power wire side. Also the brush side, if you're using just 2 wires, because they only have 2 inputs. If you're using brushless with 3, then I recommend these. I believe I think they're called the MT60. Not 100% sure what they were called. But these have 3 prongs. So you can match that up to the 3 wires here. and then the 3 wires on the motor. Then another option is if you get these bullet connectors that match what's already on the motor. I like to replace them though with that. It's a little easier than you just plug in one thing. Instead of bullet connectors, you have to do each at a time. But it's all up to what you guys want to do. And you can also just directly solder them if you don't want to use a connector at all. That works too. And then if you step up to the higher power, more heavy duty stuff, then I would recommend using XT90 connectors. They're a little bit bigger, they can handle up to 90 amps continuous, and they can go over that for a short time too. And then this specific motor that I bought actually came with the bullet connectors, so that's what I'll use on this end, and then use the XT90 on the power plug input. And then that should cover getting the basic power connections done. So if you're using brushless motors, like these, the ones that have the sensor cable, so you can see this sensor cable sticking out, they come in different shapes and sizes, so I'll try to cover most examples here, and I'll try to explain to you how you can figure out any other styles. So you can see that this one here actually has a whole extra wire compared to this. This is the larger motor versus the smaller brushless one. So you can see already they're not really compatible. So the way that you get these to work, first let me explain what the plugs are. So on these two different boards, there's 2 different ports. If you look at the instructions here, this is the book that comes with this controller here. So this is the sensor port. They're called Hall sensors. They can detect like the rotation of the motor. And what that port wants to see is positive and negative, and then if the motor has a temperature sensor, and then the 3 wires that go to the Hall sensor. And from my understanding, not totally sure, but I believe the Hall sensors can be in any order, because the software has a calibration thing that will detect which is the correct order on the software side, I think. But I'll show you what I've done here to make this work. So for the most part, the sensor cables coming out of your motor will match these pins. The only case is if your motor does not have a temperature sensor, like this one does not, it will only have 5 pins instead of 6. So let me show you this example here first. So first of all, on this board, that port is kind of blocked by this piece of plastic, so I'm going to use a knife and cut that open. So I got that cut open, and you'll notice our motor, it can plug in here, but since this is 6 pins and this is 5, the pins are not going to line up right. So this controller actually comes with a little short Hall sensor wire here, but neither of these plugs match up to our motor either. So what I would recommend doing is we're going to take off this plastic plug and then put it on this one instead. So let me show you how to do that. So if you take an X-Acto knife on these plugs and you put it kind of under that tab there, it should pull up. See how I kind of put the knife under it like that? Then you can pull the wire out of there. So I'm going to do that for all these. So here I have all the wires removed. Then I'm going to go and kind of push them in just a little bit so they're not bent out, and then that's ready. And then we'll have to also remove the 5 wires from here. But when you do that, maybe take a picture of your exact colors, keep them in the same order as you take them out. And then to explain what we're actually doing here is we're going from the 5 pins to the 6 pin plug so it can fit on the board. Like I mentioned, this motor does not have a temperature sensor, So all we're really doing is we're going to take, like this is our plug here, if it's 5 pins, we're going to take the 5th wire and just move it over one slot. Then all the pins will line up with what's on the board. So like if we're looking at it like this will line up with the diagram here. So the black wire is ground. The 3 colored wires are the 3 hall sensor wires. And then there is no temperature sensor. The red wire is the plus 5 volt wire. So what we're really doing is just taking that red wire and moving it over into this new plug. So I'm going to take, just like I showed you, take these connectors out, and then I'm going to push them in here. I'll show you the end result. So here I have all that done. You can see the end result was we basically have the same plug still, except the red wire now is one slot over. So now if we take our board, this should plug right in there now. And then just to verify on the chart, red should be 5 volts, and it should be universal on whatever connector. You might have different color hall sensor wires, but it should be black on this side, red on this side. Skip the temperature sensor if you don't have that, and then the 3 hall sensor wires. So it seems a little complicated, but once you understand it, there's not that much to that. And then to show you the other example here is on this controller. It actually has a cable that comes out with the same type of socket, and this motor actually has a temperature sensor in the motor. You can see it's similar colors, black on this side, red on this side, and then it has an additional white wire for the temperature sensor, and this actually directly plugs right into this specific controller. And then I got one more example. Here I have another one of these medium-sized brushless motors with that 5-pin connector that we just modified. So this is back to how it was. And then in this case, let's say you're using that on this motor controller. You can see we have 5-pin and 6-pin. And you know that doesn't work because the red wire doesn't line up here. So in this case, it's actually easier on this end to remove the white wire and then shift the red wire over one slot to line up with that. So that can work too. So I hope that makes some sense about how to physically set up the sensor cables. So when you're soldering on the connectors for the brushless motors, I should mention this is how I have it laid out. So for the brushless motors, the middle wire should be considered ground, and then the other 2 wires can be either side. So you can flip those, but you want the middle wire to run to the ground wire on the motor, which should be typically black, and then the other 2 wires don't really matter. But you can also see on these plugs here, they actually are labeled, so plus, minus, and then ground. So, and then also, if you use these specific connectors, you should preload these caps just like this. So then after you solder on the wire, then that will clip on there and close it off. So you can see how I have that. They have that little notch on top that will line up with that notch there. And then I'd recommend using the plugs just like this here. So here I have all the 3 examples set up and ready to program. So here the brushed motor. See, I got the XT60 connector and then another XT60 connector here, and not using the middle wire. And then the brushless also XT60 connector and an MT60 connector. And then, like I showed you with the balance port, we got that set up where we moved that wire over since it does not have a temperature sensor. And then this larger example, we have XT90 connector. And then I used bullet connectors that came with the motor. And the black should be the middle wire. And then the two colors can be either side. You can flip those to flip the motor's rotation if it's reversed. And then the sensor port actually matches that one, so plug that in there. Then the next step will be to actually start programming these. Before you start programming, make sure to read through the manual that comes with your specific controller. I noticed on this manual, it actually has a very specific thing. It's talking about if you update the firmware, make sure to turn off this phase filter. Just make sure you look through the manual in case your controller has really specific stuff. So to get the software, it's called VESC tool. So you can just look that up on Google or look in my description. I'll put a link in the video. So their main website here, if you go all the way down to the bottom, you can see they have paid versions, but the free one works just fine, way at the bottom here. The only way to get it is you check out, so you add it to your cart, and then you act as if you're buying it, but it is free. So you can see I got an email here with the download link, so I got the program downloading. So here I have the brushless motor hooked up, ready to program. So you're going to want a battery, and you can use, I'm just using this to show you in the video, but use whatever you're going to actually be using in your vehicle. So connect a battery to the controller, plug in the sensor wire, plug in the motor, plug in the USB cable to the computer, and then also have your radio connected with the radio turned on. So everything's on, and then we're going to open up the program. So I also put the motor mounted just temporarily. You can also do this whole setup while it's installed in whatever vehicle you're using, but you want to make sure nothing's on the shaft, because the motor has to do like a calibration, and you can't have a load on the shaft or it will mess with that. You'll see in a second here. So here I have the program opened up, and I'm going to go ahead and plug in the USB. And it should pop up here that it finds a device. If it doesn't, maybe try a different USB port or just re-plug it in and out. And then over here I'm going to go to Auto Connect, and you can see it connected over here. And then it will tell you that you can upgrade the firmware of the speed controller, but it's saying it's not required. So I'm going to skip it in this case. However, if you wanted to upgrade the firmware, there's a button over here where you can do that stuff here. I'm not going to do that because we don't really need to use many features with the Snowcats and stuff. So then next step will be to set up the motor. So I'm going to click this button here. This window will pop up. I'm going to hit yes to that. It's just asking if you want to read the default settings. So then on here, this is how we actually set up the settings for the motor. So I'm going to click on the generic one and go to next. And then depending on your motor, like for this one, for example, we're going to go ahead and pick the medium outrunner. You can see that there's other options here for in runners and different stuff like that. And this whole thing, by the way, is only for brushless motors. Check out the other part in this video for how to set up a brushed motor. It's a little bit different. But this, so I'm going to pick this. And it depends, you can kind of see the picture as an example. So I'm going to click next on here. And then read that warning, and then go next again. Then it's going to ask you about your battery. So since I have a 3-cell hooked up right now, it looks like it detected that. Battery cell is 3. If we scroll down, 6 amps should be good. It just wants to know approximately what kind of battery is going to be used on it. And then I'm going to go ahead and click this, the advanced here, and we can set a maximum limit to how much current can be pulled through our battery. So in this, I'm just going to set it to 50 for right now. Depends on what battery you're running. And then how much regen can the battery do? Like how much charge can it take? I'm going to set this to 5, I guess, for now. And these settings kind of depend. Like, I'm going to be running a larger battery once I get it in my SnowCat. But for now, just to show you guys, it's kind of like a recommended stuff. So once you got that set, then you go to next. And this page you can completely skip because we're not going to enter in pulley and wheel data and stuff. That's if you're using like a skateboard. So then when we hit run detection, you're going to want the motor supported somehow on its own so it can spin freely. And then when we start this process, you'll see it's going to read the motor and the Hall sensors and try to read what settings it should be using. So you'll see it do kind of some weird stuff. And you can see how slowly that's spinning. It's because that we got that Hall sensor connected. So I'd really recommend that section of the video where I showed how to hook up the sensors and stuff. That's worth taking the time to figure that out. So then when it's done, you want to make sure, so you can see it actually read the current. That's what these motors were rated at, was about 50 amps. So it read all that correctly. Does not have a temperature sensor. And then sensors should say Hall sensors here if the wiring is correct. If for some reason the wiring is not reading correct, this will say something else. So you want it to say Hall sensors. And then here it just asks if you want to check what is forward or reverse, but it kind of depends on the radio channel. But I'll just click forward as you can see. But yeah, it'll depend, and you'll in the end you'll probably use your radio settings to adjust the direction of that. So that sets up the motor's power. So now if we click finish, then the next step, we have to set up our input. This is what actually will control the motor. So we'll click that. There's this setup wizard you can walk through here. And there's different options, but we'll use the conventional RC receiver. Click next. So then on this screen, we have basically the radio signal. So I'm going to move, I have it connected to this channel just for now. So when I move that joystick, you can see on the bottom that the range is moving like that. So if you move the channel up and down, and then you hit apply, now we should see that, you can see when I move the stick, it's going to approximately 100 and then 50 and then 0. That's how you map your radio stuff there. Then I'll hit next. And then this screen, there's quite a few options. The way that the motor behaves is you have all these settings here. So I would recommend duty cycle. This will work very similar to other remote control speed controllers, but you can play around with the other stuff. Current is kind of weird. It's really meant for like high-powered like skateboards and stuff that you're riding on. It just kind of behaves differently. It doesn't really work with a tracked vehicle though. You don't have as much fine control. Duty cycle works, and I actually haven't tested these other ones here. But let's pick duty cycle. And then you don't really have to mess with any of these other settings. And then on the bottom here, it says write configuration, so I'm going to click that. And then next, and that should be all set up. So now if I move my joystick, it should control the motor. And you can see it has like really nice low-end control because of that Hall sensor that's in there. So then that sets up like the really basic function of the motor, and that's really all I would recommend doing. That normally will work very well. However, this program is really advanced, like way beyond my knowledge of this stuff. But you can come in here and there's all sorts of settings. Like you can adjust the current in here, like braking current and stuff, which it doesn't really apply to a tracked vehicle because it's just not moving that fast. But yeah, you could look through this, but really what we've done is probably all you'll need. But options certainly there to go really in depth with this. And then when you're all done, before you unplug anything, you're going to want to go over here, and you can see these little buttons here. So there's motor config and then app config. So the top button will read what is currently programmed to your controller. The middle one will reset it to defaults, or read defaults. Yeah, I'm not exactly sure on that one. But the bottom one's what we're after here. So when you click that one, any changes you've done will be saved out to the controller. You can see it says write. So we're going to click on the M and the A. So that'll save out both of our settings. And you can see when you click that light down there blinks, to let you know that it's actually being written to it. And then that will be all set up there. And then keep in mind, if you ever change battery sizes, you'll want to go back through this to tell it all the new data about battery cell counts and stuff. Then it knows to limit the controller when it starts getting low on battery and stuff like that. And then same with if you do any major changes to the radio, you'll also want to come back in here and rerun that input setup to remap the control. So here to show you how to program the larger sized brushless motors using this other controller here. I got a test battery hooked up just for now to show on the video, but use the battery that you will be using in your vehicle, like the higher voltage stuff. And then I have it connected here to the motor with the Hall sensor, and then I have the USB cable plugged into my computer and the radio controller. You can see here this port is plugged into my radio, which is turned on. And then I also opened up the software, and then this specific controller comes with a warning telling you do not accept the default settings, and then make sure that this setting is turned off. So when I connect it here, if you go to auto connect, when it asks us about the default stuff, I'm also not going to update the firmware. I'm just going to leave it with what it has. And then we can go where it was talking about this, just to make sure that's set. So motor settings, FOC, enable phase filters set to false. So let's see here, motor settings, FOC. Then up here to filters. And So that filter list is empty, and I figured out it's because I missed what it said here. Is basically it comes with firmware 5.2. If you want to update the firmware to any of these other versions, then you have to do this. But if it's still on 5.2, then you don't have to do that. And if you look in here, if we go on the firmware page, it is on 5.2 there. So everything should be fine then. So next step, to actually set up the motor, I have mine mounted somewhere because this needs to be able to spin freely. Don't have anything connected to the shaft. So if this is installed in your transmission already, maybe just take the sprocket off or something so it can spin on its own. Then we're going to go in here to the setup motor, and then this page will start opening up. So if asking if we want to restore our defaults, I'm going to click no because that page was telling us not to do that. And then I'm going to go to generic, next, and then this one I think is still a medium outrunner. I'm gonna go with the medium one still because it's only a little bit bigger than the other size. I think the large outrunners are for much larger motors. So we'll go next. Yes on that. And then it's asking about battery voltage. So it auto-detected that I'm using a 3-cell, but make sure it matches what battery you're using. Same with the capacity. And then I'm also going to come down here and turn on advanced. And you can set limits, so the controller will limit if it goes over this current. It will software limit it to not be able to pull that much, so it's a lot safer on the electronics. I'm going to put the battery current just for now at like 50, and then regen at like 5. You can play around with those settings, and if you have a much larger battery, you can increase that, stuff like that. Then next, this page you can totally skip because we're not going to do the wheel diameters or pulley or stuff. So then next, like I said, make sure your motor can spin freely, and then we're going to hit run detection, and it's going to spin the motor and try to read its certain values and settings. So just wait till it's done doing its thing. And like I said, if you have something on the shaft right now, it will mess with all of its calibration stuff. It has to be able to spin freely. So then once it's done, you can see what it came up with here. So it's saying the motor is being read at about 60 amps current, and you want to make sure if you have your hall sensor hooked up that it says it here. If it doesn't say that, then you might have the pins in the wrong order, so you have to look into that. And then we're going to click OK, and then you can test it to see which is forward or reverse. But it doesn't really matter because we can change that on the radio itself. So then I'm going to go to finish. Then the last step is to set up the controller's input, like our actual radio controller. So I'm going to go to input, and then next, and it's going to ask us what type of input we want to use. And we can do the RC controller. And then this page is setting basically the limits of the joystick. So like when I move my, I have it set up just to this for the test here. You can see when I move that, it goes up, but it doesn't quite reach to 0. It goes past 100. So with basically move the stick fully up and down, and then hit apply. And then now it should read about 50 centered, and then you can see it's 0 and 100 pretty close. That's how you center that. Then we'll hit next. And then this, you have quite a few options. The very top box here, these are all the different ways that it can control the motor. For our purpose, for RC stuff with the tracked vehicles and stuff like that, we're going to be using duty cycle. These other ones are more suited for like ride-on like vehicles and stuff. They don't quite have as fine of control as the duty cycle. And duty cycle is how most like toy RC speed controllers already work. And then we don't need to mess with any of this stuff. So we'll go ahead and write configuration and then hit next and finish. And then just to make sure everything gets saved, I'm going to come over here and hit the motor right and then the app right. And then everything should be good. So if I move the joystick, so yeah, that's the basic setup for that. And then, like I mentioned in the other parts of this video, is you can go really in depth and do a lot of other tweaking and stuff. This program can do quite a lot, but for our sake, really just the general setup and the input is all we need. And then if you ever change your battery, you'll have to rerun this configuration so you can set the new battery data. And same with if you change like your control around quite a bit and it loses the range, you're going to have to come back in here and redo the setup input. So here I have a brushed motor all hooked up here. So this is what it should be like. Got the motor connected, or I have a test battery connected, but make sure you use whatever voltage you'll be running in your machine. This is just for a test. Then I have it connected here, and then the USB cable to the computer, and the signal to the radio, which is powered on here. Then I have the program opened up. So the device should show up here. If it doesn't, maybe try replugging in the USB or a different port. Once it shows there, I'm going to go to Auto Connect. And it should connect. And I'm going to skip updating firmware. We don't really need to update the firmware. You can if you want in this window, but I'm not going to on this here. And the brushed motors are different than the brushless ones to set up. We do not use the motor wizard here. So to turn it into a brushed motor, we go to General, and then change motor type to DC. And then you'll also probably want to set up your current. So the controller can limit its current to protect your battery and stuff. So depending on your setup, I'm just going to leave mine at default, but you can tweak that there. And then also we'll want to go into the voltage tab here. So depending on your battery setup, you want the controller to be able to cut off the power when the battery gets low. It's the same thing that most RC cars use, like the LiPo cutoff, except in this you got to manually set it. So at the bottom they have a calculator just for lithium ion batteries. So like say we're using a 3-cell LiPo, I'll hit that and then hit apply, and it should put the right numbers up here, or you can manually adjust that. And then that's pretty much it to set up a brush motor. You can look at the other settings, but those are the important ones. And then when you have that set up, we're going to go over here and click the right motor button and then right app button. And then one last thing to do is go back to the wizard, and we still have to set up our input for the controller. So we'll go in here and click next. And then we'll select the RC receiver. And then here I have it connected to this joystick just for the test here to show how to set it up. So I'm gonna move the joystick down and then up, and then you can see that moves there, but it's not quite centered. So once you move it down and up, center it, hit apply, and then now it should read 0 or close to it, and then 100. So that's pretty good now. Then we'll go to next, and then this you can play around with. I always set it to duty cycle. Has a lot more fine control, but the other ones are kind of more suited for like wheeled stuff, I guess, like skateboards and scooters and things like that. But for this tracked vehicle, duty cycle works really well. So then I'll write the configuration and click next and finish. And then just to make sure everything gets saved, I'm going to do this one more time. Write both of the motor and app data. Now when I move this, it should spin the motor up. So there we go. So that is all configured now. And then, like I mentioned in the other ones, you can fine tune quite a lot of different settings. Like they even have this whole specific menu just for DC motors. It's pretty good though, just default. But yeah, you can mess around with this stuff if you really need to. I've never really had to. And then when you're all done, you can disconnect and unplug everything. So that wraps up the video. Check out the description for timestamps to skip around to whatever motor setup you're using. And I hope this wasn't too complicated. It's really simple overall, but I just kind of went in depth to give you a really thorough explanation of everything. But yeah, let me know thoughts and stuff, and thanks for watching.